All right, so let's talk about this. During your activity, you had 12 antiderivatives. When you did anything that involved like x to a power, okay, anything that involved x to a power, Anthony, what was the strategy you used in Pod 8?
We ended up making a equation there. So we have 1 over n plus 1 times x to the n.
1 over n plus 1 times x to the n plus 1. Okay, so what does that mean? What did they do to the power? They increased it by 1. And then what did they multiply by? 1 over what that power was. Okay, so they took that power, added 1, and then divided by it, or multiplied by its reciprocal would probably be a better way of saying that. Is that what does that make sense with the problems from your activity? Okay. Okay. We added a power, multiplied by its reciprocal. Added a power, multiplied by its reciprocal. How about for these sine or cosine ones? Okay, for the sine or cosine ones. Lauren, what was your strategy when you worked on those in Pod 5?
We found like the derivative of like sine or cosine tangent, and then you had that, and then you had the same what was on the inside, and then the antiderivative of the inside.
Okay, so we have to account for the chain rule, right? Which is why you did that. So whatever was in the inside, basically the coefficient of x, you needed its reciprocal out in front to account for that chain rule that you would do if you took the derivative. Okay? Sean, you had a really good point. Could you share with the class what you were wondering?
You could like add plus 1 or plus 2 or whatever to the end of it and still be right.
On any of those antiderivatives, could you add a plus 1, plus 2, plus 2018? Okay. So there could be plus any constant after those expressions and they would still be right. Do you agree?
Absolutely.
Okay, so what we're going to do is anytime we take an antiderivative, we know that we could have plus a constant at the end. Because the derivative of a constant is?
0.
Okay. Have I really taught you anything yet?
No.
Yes.
You figured it all out so far.
That word is constant.
Let me teach you some notation. Okay? Antiderivative. Okay? So we're doing derivatives, but we're doing them the other way. Okay? is an antiderivative of little f? As long as you can take the derivative of the antiderivative to get to f. Okay. What you are going to see when I ask you for an antiderivative is this symbol right here. This is what we call an integral. Okay? It looks like a super skinny S stretched out. Okay? This is an integral symbol. And when you see the integral symbol, it is asking you, oh, I forgot something. Oh, please don't be mad at me. You need to add that in. I got super excited. I didn't add it in. Okay? This is asking you, hey, take the antiderivative of whatever is inside here, and then this dx is telling you with which variable to take the antiderivative with respect to. Okay? Right? We have that dy dx symbol for when we take the derivative. Well, now we have the dx inside of our integral telling us which variable to use. Okay? So what this is saying is the integral of f of x dx, which means the antiderivative. So the antiderivative of little f is this big F plus c. And that is the case as long as if you take the derivative of your answer, just like you were doing in your activity, to get back to what was inside that integral symbol. Okay? The only thing I've done up here is put a symbol up there. That's going to be your kind of your green light. Hey, take the antiderivative. Mm-hmm. Okay. If you flip through your book, sometimes this integral symbol is going to look like this, and sometimes there will be numbers on it. Okay? Since there are no numbers on it, this is what we call an indefinite integral. There are no numbers that we are going to plug into it right now. Okay, so it's called indefinite. Next semester, I'll teach you what's called the fundamental theorem of calculus. There'll be numbers on that integral symbol, and we would call that a definite integral. So a couple things I want to point out. Derivative and antiderivative, they kind of have that inverse relationship, if you will. So let's think about things like this. If I have the integral what's the antiderivative of the derivative of f? The antiderivative of the derivative, they kind of like cancel each other out, essentially. The antiderivative of the derivative is the function itself. Same thing. The derivative of the antiderivative would be the function itself. Okay? I just want you to kind of understand that those two would undo each other. Today we're really going to focus on the power rule. Tomorrow we're going to focus more on some more complicated ones. Okay? Along with maybe some natural log, and exponential ones. Okay, maybe some trig ones thrown in there too. Okay, but let's just focus on the power rule for right now. So please tell me, what is the derivative of a constant?
0.
0. Okay. So we know that the antiderivative of nothing is a constant. What's the derivative of something times x? Something. Thanks for saying something. So when we talk about the antiderivative of just a number, it would be that something times x, but then don't forget we could have that plus constant thrown in there. Because the derivative of a constant is 0, so we always have to account for that at the end. Okay? And then pod 8 back there came up with this for us. We know that the power rule for a derivative is this right here. We take the power, multiply it out in front, and decrease it by 1. So since that's the case, in order for our antiderivative to work, when we have x to a power inside of our integral symbol, like pod 8 said, we need to increase the power and then multiply by its reciprocal. And then, of course, now we have to remember that plus c. Okay. These are really the only rules I want to worry about today. We'll talk about more tomorrow, but just like we did with derivatives, if inside the integral it doesn't look like that, then you need to rewrite it so it does. Okay? 3 examples. We'll start off easy. Okay, so in this integral, there are 2 terms. That's fine. We can take the antiderivative of each term separately. So we have 2x to the 4th. Okay, let's think about that x to the 4th. With our rule, we said we had to increase the power by 1 and multiply by its reciprocal. So we can just say that that's 2/5 x to the 5th power. Okay, plus x cubed. What do? We increase the power and multiply by its reciprocal. And don't forget, there will be one of you that will forget plus c on every single problem on Wednesday. Your goal is to not be that person.
It's gonna be on half. It's gonna be one kid half the class. That's it.
Hi. I do.
We all fail.
Okay. You don't have to right now, but sometime Miss Williams in the athletic office needs to see you. Okay? You know what that means? You know what that is? You know who Miss Williams is? Okay, perfect. Second example. rewrite it to be x to the n. X to the what? Thank you. X to the negative 2/3. So now when we take our antiderivative, we can increase the power by 1, which would be 1/3, multiply by that reciprocal, which is 3, and tack on our plus c. One more example, that's it. And you'll get to start your homework in class.
It's a real party you're missing for your
Wake it up. Is that a cube root?
That is a cube root. There is no such thing as a product rule, or a quotient rule, or a chain rule when we take antiderivatives. But we could write this as x to the
2/3.
Okay. This is x to the 1/3. This is x to the 2. When we multiply and we have the same base, we add our exponents, and 2, aka 6/3, plus 1/3 would be 7/3. So our antiderivative would be x to the 10/3 times reciprocal 3/10 plus c.
I forget it. I haven't forgot to write
Like, bro, we can plus all of them.
All right, so I don't know if you've noticed, but the winter holidays might be my favorite time of year. I decorate for them. I have jewelry that I wear in celebration of them. I also have a worksheet that may or may not be holiday themed. Is that okay?
not show any of my work.
The worst part that do they? There's nobody to the right. Dylan doesn't do it though. I attack him.
Okay, so look at your worksheet. Numbers 1 through 10. Look at your worksheet. Numbers 1 through 10, I just want you to practice rewriting into x to the n. Because if you can't do that, you can't do the power rule with your antiderivatives. So 1 through 10, you're just rewriting as x to a power. Then 11 through 20, you're actually finding the antiderivatives. There are 8 minutes left in class. I bet you could get a very good chunk of this done right now.
Wait, what are the letters?
The letters go down below.
Oh.
So yeah, so like the answer to number 1, whatever it is, you would find 1 down below in these blank boxes and fill in the letters. So then it's going to spell.
Yeah, I really thought this was gonna spell something, but this does not because the word I know.
Okay, you don't have to do that part. I just really want you to do the next part.